Welcome back my favorite Python programmers to a brand new video, and in this one our farm is growing fast, but we have a problem. Our planting system isn't fully optimized yet and we're wasting time and resources. Today we're taking things to the next level by building smarter algorithms and unlocking new tools that will help us accomplish that. Along the way, we'll be tackling more advanced Python concepts like defining functions, importing files, and code optimization. And as always, I'll be teaching you all of this along the way. So without any further ado, let's go ahead and get started. So this is the farm that we left off with the last time. Now I did make a few tweaks, nothing too special, where I increased the speed of my drone. And as you can see, the drone now requires cactuses, and if we scroll down, this is the cactus that we have right here. I don't know if we'll unlock cactuses today, but what I do want to do is I want to upgrade a few things. So I've upgraded the grass as well. Let's go ahead and do that again, and I will just run not the grass, the hay, and I'm going to just run the hay. So as you can see, sometimes it does something weird. I'm just going to go back and do this. Now what we'll do today is I want to expand, first of all, using 500 pumpkins. That shouldn't be too hard. I want to refurbish these farm trees. So let's go ahead and first of all fix this, because last time we left off, this was extremely ugly, and I don't want to have that as my reputation, because obviously this code is horrible. So we need to refurbish it, and while we're doing that, the hay will just keep coming and coming, which is great. Now, to do this, I thought this would be a great way for us to learn how to work on the trees, or actually how to work on reshaping and redoing our code. So I've got my trusted Wacom right here, and I'm going to go ahead and open up a whiteboard. So right here, as you can see, I'm going to go back and check what we have right here and then start refurbishing it. So the first thing I want to do is, instead of always calling this get world size right here, I want to actually create a variable. So I will create like a variable that will hold the get world size that I can use whatever I need down here. The loops that we have, the outer loop for the for I and the inner loop for j, are good. The while true is also good because we want to keep doing this all the time. So the while is gonna stay the same. I'm gonna call this something like this. I'm not gonna write it. This is going to be pseudocode. So this will be the while right here. Inside we will set this variable. So I'm going to use the red to set variable, which will be the world size, and then we will have the for I, which will be the outer loop, and the for j, which will be the inner loop. So all of these things stay the same. Now, how do we refurbish this part of the code, this messy part where we have to check if multiple times, we have to harvest multiple times? This is something, once you look at it, you have to think to yourself, okay, this is completely wrong, we need to redo it. One thing that we see in common is that for I, modulo 2 equals 0, which means that whenever I is even, we check if j is even, then we are planting the trees, okay? And then we're checking if j is odd, which is for the else right here, and then j is odd, then we're planting this. So immediately we should start thinking that if I and j are even, we are planting trees. When I and j are uneven, we are planting a bush. But before we even do that, we need to check that if we can harvest in the first place, because everything that we're doing right here, like the harvest and the planting and the harvest and the planting, you can see that all of it is checking, first of all, if we can harvest. So what you need to do is you need to put the if harvest on the outside. And that is the key thing. This will save us 1, 2, 3, 4 lines of code when we just put it on the outside. And if we can harvest, then we will simply harvest. I mean, it doesn't matter if I or j are even or odd, it doesn't matter at all. If we can harvest, then we will harvest. That is the first step. And once we harvested, then we can start checking for the conditions. So what will be the simplest way that we can set this condition to? Well, if you notice something, right here we're checking if I modulo 2 is equal to 0. And if j modulo 2, which checks the remainder of the division of j by 2. So if the remainder is 0, that means that it's an even number. So if both of them are equal to 0, then we're planting a tree. But if you look right here in the else, if both of them are 1, which means that they're both odd, we're planting a tree as well. So now you can infer if I modulo 2 is equal to j modulo 2, we are planting a tree. So we can say that. So let me, because I by the way, like I've done this on the side because I just didn't want to waste too much time while doing this. So right here, if we say I modulo 2 is equal to j modulo 2, then we can plant entity dot tree, and else we plant the entity dot bush, and that will fix everything, and we'll put everything down here under the harvest. And of course, only if we can harvest. Once we've harvested, then we check if all of that. And this should make our code much, much smaller. Now, I haven't written the code. I'm not sure if this will work for sure, but we will have to try and see if it does. So I just dropped my pen. So I'm going to create a new code file right here, which I'll call the optimized farm trees, or wood. I'll call it just farm wood because we're literally farming wood. So in here I'm going to start with a while true. So just like we've said, we're gonna have a while true on the outside. We're going to set the world size to a variable. Now, something that's very important, world size equal to get. I'm not sure we have the ability to do that. Okay, thank you. get underscore, where are my suggestions? Get world size. And will this allow us to do it? Because we haven't unlocked variables. I just noticed it. I thought about it as I was creating this algorithm right here. So, I mean, they're not causing us any errors, but we will unlock variables nonetheless. And variables, if you look right here, variables can be thought of as a name container that can hold a value and they use the equals. So for example, a equal 5, now we can use it, something like this. So if, or a equals 5 for I in range of a, which means it will be 5. This is very rudimentary. If you're still unsure of how variables work, this is one of the simplest things, but they introduce it at this point. So now we actually have the world size. So instead of always calling this function again and again and again, we just call it one time and it just works. So I'm going to say for I in range, and now instead of calling the get world size again, which takes a little bit more time from the processor, we can just say world size, and now this is much more efficient. And now for j in range of world size, boom, we have this. Next thing we said we're going to do is we're going to go ahead and we're gonna check if we can harvest. So if we can harvest, we will harvest. And now we're going to say if I modulo 2 is equal to j modulo 2, I don't know why I did not leave any spaces for you there, then we're going to go ahead and plant entities dot tree else, which means that they are different. And yep, it has a problem with setting the indentations properly. Plant entities dot bush, right? And whoops. And there we go. Now moving north and south should be pretty easy. So once we finished up with going on the, so remember, we go north, 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 north for every single time we plant. This is in the inner loop. So we move, whoa. Okay, so we move north, please. Can't I get a north? Can I get a north? Can we get a north? Perfect. And then we move every single time we finish the loop on the, or actually wait, oh, this should be inside of the loop, and then once we finish with the J, so once we've moved all the way north, keep in mind, so this move north, notice the indentations. It belongs to the J, which is moving upwards, right? Moving north, and then when we finish with J, then we start moving east. If I'm not mistaken, east, yes, east is on the right, exactly. So we're moving to the right, which is the east. So yeah, I mean, look at the difference between these two algorithms. Now, the question is, will this work? I'm fairly certain that it will. Oh, look, you can actually dock them together. Did that happen automatically, or okay, just luck? So, oh no, it did. All right, so I'm going to stop the hay because we have 53,000. And I'm going to run the farm, so just in case you weren't on the previous video, you can see what happens right here. So boom, as you can see, look at that. Our code worked perfectly fine. So you can see that the trees are planted on the diagonals. And if you don't know why we're planting trees on the diagonals, it's because it's one of the rules that they imposed on us, that trees like to have space, so they have to be on diagonals. And we've built like an entire algorithm in the previous video. But now, it used a very inefficient code. Let me stop this, let me clear it, go back, and then let me optimize the farm wood and see what happens. And it seems to be doing very, very well. There we go. And you can see that the trees are only on the diagonals, which is perfect. The bushes are being added in between so that we don't waste any space on the farm. And yep, there we go. This is the optimized farm wood. A few things that I don't like, which we will need to fix later on, is that these trees are taking way too long to grow, so that we will need the watering, and we will delve into the watering later on. But for now, let's actually expand the trees. I mean, look at that, we have a lot of hay. Now we can farm a lot more wood. What else can we do? Okay, now that we have that, I want to expand my farm, and for that we need pumpkins. So we've already built the algorithm for the pumpkins. I'm just going to clear this, so get back to the beginning and start farming. Okay, so I've left it for a little bit, but as you can see, something that we did with the farming pumpkins is that when you have multiple pumpkins next to each other, they form this big mega pumpkin. So what I did is I said that I want to, while true, for I, for j, get world size. Of course, this needs optimizations such as this one. But what I did is I wanted to do a few flips to allow the pumpkins to grow and form one big one. Now, the problem with pumpkins is that, as you can see, some of them actually die, which is not good. So what I wanted to do is I wanted to, as we're waiting, I'm gonna wait until I have like 400, 500. Okay. So what I wanted to do, and I actually want to increase the yield of pumpkins. Yeah, that should be good. Our drone stopped harvesting pumpkins because we are out of carrots. So I'm going to set the carrots to run. What do we need for carrots? Wood. We have a fair amount of wood. Let's go ahead and make the carrots more efficient. And there we go. I will let this run for a bit. Then I'll come back to you to see, because I want to work on what we're going to be doing next. Okay, so I thought about it, and you know what? We'll leave the pumpkin algorithm because I feel it's gonna be a big one, and I don't want to waste too much time like quirking around. But I'm gonna prepare it for next time, and then we will solve it together. But before we do that, first of all, look at how amazing our farm is. Look at that, it's big. The carrots are working, but the problem is similar to the trees. Look, there are spaces that are empty. You know, like I don't like that at all. You know, like we're hovering over, we're wasting a lot of potential. And the way that I want to fix this potential is by starting the watering, because water the plants to make them grow faster, and that will be amazing. So let me take it right here. And now we're gonna start with watering. So let's look at what watering is all about. So plants grow faster when they are watered. The ground has a water level ranging from 0 to 1. Perfect. So every single ground has 0 to 1. The function getWater returns the water level of the ground it is over. So you can check what the ground, what the level of water is. As you can see, oh, we're getting water already, and it seems like the water is automatic. Okay. The growth speed of a plant scales linearly from 1x speed at water level 0 to 5x speed at water level 1. The ground dries up over time. On average, it loses 1% of its current water per second. Okay, so about 100 seconds, you're back to zero. So the question is, when do we water? Should we water like at 80%, 50%? This is something that we can like think about later on. You can use water tanks to water your plants. One water tank is automatically added to your inventory every 10 seconds. Okay, perfect. Maintaining a high water will consume... Oh, okay, so maintaining a high water level will consume much more water than maintaining a low water level. So now we're gonna start thinking about the balance that we want to create. Should we be watering the ground every single time and making crops go up faster? Or maybe we should start making the watering level lower, the less water that we have. And by the way, we're not planting any carrots anymore. Why? Because carrots use wood and we don't have any more wood. So we will use our optimized wood farming. And by the way, because we've expanded, now our planting will probably be more efficient because the trees have more time to grow. I don't know. Let's just keep it as it is. We have 4.6. What can we upgrade with our 4.6 carrots? We need bones. Where are the bones? We have fertilizer and sunflower for power. Fertilizer plant grows plants instantly. So will we even need water? I don't know. Where's the dinosaur? Majestic ancient cactus, dinosaurs, lists and functions. I want to delve into these as well, but I'm not entirely sure. I think functions will be extremely useful to us very, very soon. I want to upgrade the pumpkins. I want to upgrade the watering. Oh, let's do a lot of watering. Yeah, let's get a lot more water. There we go. So a lot more water per second. I want to continue. I'm thinking if water is even useful, if we can just use a fertilizer and to get things instantly. But still, I want to check the water. So you can use water tanks to water your plants. One water tank is automatically added to your every tank. Okay, upgrading unlocks.watering will give you an additional water tank every 10 seconds. This one. Yeah, that's what they're talking about. Okay. So now we have 1.4 water per second. Let's upgrade it even more. I feel like water is important, even though I think maybe fertilizer is better. Let's see. Fertilizer. Okay, so we receive a lot less fertilizer. So I think we'll need to do that. At some point, waiting for water to grow is just not efficient enough anymore. Similar to water, you will automatically receive one fertilizer every 10 seconds. Plus an extra one for each upgrade. Okay. Fertilizers can make plants grow instantly. So for example, use items fertilizer before we could use water. Reduces the remaining growing time for plants under the drone by reduces the remaining growing time of the plant under the drone by 2 seconds. So if there's a plant that's growing slowly, you can use the fertilizer for it to grow 2 seconds faster. Wasn't this instantaneous? Something that we'll think about. This has some side effects. Plants grown with fertilizer will be infected. When a plant is infected, half of its yield is turned into weird substance when it's harvested. Weird substance can also be used on plants, which has the effect of toggling the infected status of the plant and all adjacent plants. So if you call the use item on an infected plant, it will cure it. But if you use it on a healthy plant, it will infect it. Okay. So if you use it on an infected plant that has healthy neighbors, it will cure the plant, but infect the neighbors and vice versa. Okay. I will leave the fertilizer for later. I want to get down with the watering. So a tank holds 0.25 water. Like upgrading, you can use... Okay. This is great. I want to start using the water. I want to also... Okay. I want to unlock functions as well. So let's look at functions so that you know what we're doing when working with functions and you'll see how useful it can be. So functions, if you want, I have a video that covers functions from scratch. for beginners, for complete beginners. So I recommend that you watch the video that I will link somewhere at the top. And also I have a lot of exercises regarding functions, so you can check that out as well with a second video. So functions: use the def keyword to define the function def arg1, arg2. Okay, so you provide the functions with a few arguments, and then you have the function code inside. Also, you can provide it with default parameters. So you, for example, if somebody does not provide argument 2, you can set it as false. You can use the call operator. So this is how you call a function. This is the name of the function right here, and this is just the def keyword. So for example, right here, f42, which means arg1 becomes 42. Also see scopes. Scopes are very important because whatever variable you create inside of the function cannot be used outside of it, but it can return values. We'll see what they talk about later. You've already seen the built-in harvest. So harvest is a built-in function. And before we continue, what does the harvest return? You have to think about it, because look at where we're using it. So if it's used right here, it means that if can harvest, which means that the can harvest returns a Boolean, and the Boolean can either be false or it can be true. So right here, for example, you could define a function that moves the drone several times. Interesting. So define move on the R, so you can move it n in any direction. So for I in range of n, move in that direction. Perfect. So the def keyword signals that this is a function defined move, and the R isn't. What? The def keyword signals that this is a function definition. Move and the R is the name of that function. This can be a valid variable name. I've already told you what this is. Of course, you finish off with the colons. Colon? Is that? It's called a colon, I believe. With the above definition, the following code then moves the drone to 10 tiles. So for example, you provide it with 10. That means the range is going to be starting at what? At 0. So we're starting at 0 and going up to, but not including 10. But that means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know if I counted correctly on my fingers. When you see def function, you should really think of it as a variable assignment like this. So function equals, okay. Like with all assignments, you can use the variable before it was assigned. So function, this code will throw an error. Of course, you cannot use a function because before you've defined it. That's why we always tend to set functions at the top of our code. That's just what good Python habits require you to do. Our drone is getting at it. Look how much we've created, how much wood we have. What did we want to upgrade with the wood? Let's do more watering. Yeah, and let's yield a few more carrots. And trees need 20k hay. Let's do some hay. And pumpkins, yeah, let's upgrade everything that we can. Since we're reading and learning, this will be great. I want to start farming hay as well. Oh, trees are at max level, so 1000%. Oh, not for everything, just for the trees. Okay, understood. Perfect. So we're learning about functions. Let's scroll down. Let's see advanced function usage. So you can define a function inside of a function. No, before we do that, we have the return variable. So as you can see, this is what we're returning by the harvest. The XOR, do a flip, okay, tuples, something that we haven't seen yet. Where do we unlock tuples? We don't, we already have them, auto unlocks. Okay, I want to unlock lists as well. I'm not sure what we would use lists right now. Imports are very important because we can start importing files. So we can create different files and start importing them. That will be great. Utilities like the min and max and random, those will be also very important. Dictionaries, not sure what we'll use them for. The debugging programs, I think those will be very useful. Let's just get the debugger. Oh, a chest? What is this chest? Where do we get the chest? Oh, the mazes. Yeah, I thought that would be timing. It's about time. Let's go ahead and, oh, we don't have enough pumpkins. We don't need it anyway. We'll talk about the debugger later on, such as the print, which allows us to have the print right here. Okay, perfect. default arguments. So as you can see, I've told you about the default arguments already. I knew it was coming. That's why I'm a Python instructor. If a do I flip argument advanced functions. Functions are values just like any other value, and the def statement just acts like an assignment statement for whatever name you want to give it. Okay, so something like this. This is slightly more advanced. I don't think we're gonna need that too much. Like I don't see this too much, right? Whenever I'm writing like even advanced code, not super useful. But now that we know what functions are, let's go ahead and start using these on the watering. So what's happening in here? I want to start watering. I want to create maybe a file. I want to create a file that will water stuff. Can we import? Did we import unlock? We need, let me farm a bit of pumpkins. I need also carrots. Okay. I'll just start farming pumpkins because I want to unlock the import. Because once I have the import, I can create a file right here, which will be watering underscore ground. No, not like that. So watering the ground, interesting. What do we do with the drunken sailor? Where is the... So right here, with the watering, we could check if get water. I'm just gonna do exactly what they're doing. Just like copy, literally, and paste. Perfect, there we go. But not only that, I want to put this in a function. So I'm going to define water underscore plant underscore underscore 50. Yep. There we go. Okay, so I don't know if we should send in what's tabs and spaces should not be mixed. Did I add like that? All good. Perfect. Now I don't want to just be watering, you know. Why are we not planting pumpkins? Because we are out of carrots, and we are not planting carrots because yeah, we need to restart it. Okay, so we're checking. We water if we have water less than 50. But I also want to make sure that if water is less than 50 and we have water, what did we use? Right here, watering, which allow us to use item. How do we check? Returns the water level of the ground. Okay. How do we check how much we have? Number of items. Okay, so in here we also check, and number of items is dot water is greater than 1. Yeah, just greater than 0. If we have water, we will start watering the ground. Colon. There must be a colon. Okay. I was thinking of the and. Wait, we already have the and. Why did I? And? Oh yeah. Sometimes in different languages you use the and differently. So now we're watering the plant. So inside of the wood, inside of the pump, everywhere, we want to add this everywhere. So let's look at the importing. Unlock importing. So basically the way that importing works, we're learning so much in this video. Oh my god. Putting all the code in a single file becomes unmanageable. Import the statements, import file name. This is the simplest form. So import helper. So let's say you have defined say hello, print hello helper, import helper, helper.say hello. So this is what I want to do. I want to, you know what? Instead of calling this watering ground, I'll just call it watering. And I will first of all do it with the pumpkins just to show you how it works. So I'm going to be first of all importing the watering. So import watering. Is that how it works? No, I don't think. Whoa. I don't think. watering. Will that work? I don't know. And then I'm going to say if we can harvest, and then watering dot water plant under 50. And I want to do it to the carrots first. So right here, I want to import watering. It's not giving me suggestions, which is giving me a bit of anxiety. But it seems to register. It seems to be working. So look at what we'll do. So right now, let's just proceed and look at how carrots are not being farmed because we don't have any hay. Okay, so let's go ahead and reset, and I will see you in just a bit once we have a lot more hay. And by the way, while we are farming hay, as you can see, for example, the hay does not require any watering. The carrots grow slower. Pumpkins grow a bit faster than carrots, so maybe pumpkins do not require watering because like we're going through, and it's like, I don't think it's gonna be that crucial for us to give water to pumpkins, to be honest with you. I'm not entirely sure about this. I'm gonna actually, maybe there's no harm in doing it, but still, I'm a bit uneasy about it. I don't want it right now. I don't want it right now. And yeah, I think we have enough hay just to plant a bit of carrots, just to see the experiment. So, by the way, maybe I also need to integrate this clear into the farm right here. Anyway, let's go ahead and plant carrots. So as you can see, it takes about, and I want to show you what the problem, oh, hey, so we had a small issue. I ran out of space on my PC, so I had to start all over again. Not all over again, but I had to pause in the middle. We were doing something that's very, very exciting, and that was watering the ground as we were creating the carrots. So I'm going to run this again, because I exited out of the game and just continued my day. So as you can see, something is happening when we're watering the ground. And as you can see, the carrots are growing much, much faster. So remember before, all the carrots used to take a long time. Some of them would grow, some of them wouldn't. So yeah, as you can see, we are doing extremely, extremely well. Something that I am not entirely sure of what's happening, that is, are we watering all the time? Because we're checking if the get water is less than 0.5, but it seems, oh, look at that. So sometimes this line is not running. So look at that. The water is increasing instead of decreasing, and now we're going to see that at some point this line right here will get highlighted, which means that the water was used. So, see? So, as you can see, we can visually see the soil not being watered. So the deeper shade, so this is soil that is not watered. So you're gonna see it's gonna become a little bit deeper. Yeah, I think that's what's happening, if I'm not mistaken. But as you can see now, our carrots are being farmed so much faster. And to be honest with you, like we are almost at the end. Maybe I unlocked the debug, so I can check if that part is running. How much do we need? 33k to increase the yield of carrots. Why are carrots? Yeah, we're not getting that good of a yield. The hay is almost over. Honestly, this was the end of the video. We've done so much today. We've started adding water. We've started, let me continue farming the carrots. So we've started adding water. We've started using the import. Before I go, I want to just tell you a little bit about the import. So each individual rectangle or square that we add is a file. And by the way, these file names are very, very wrong. You should never name your files with spaces or weird characters in between. Your files should only have underscores at max. That's why I called it watering. And when we imported watering, we now have access to all the variables and functions that are in the watering. And why did I make a file out of it instead of just copying and pasting this right here? Well, maybe, oh, see, we ran out of hay. Maybe I'd like to start farming hay. right? And watering it. Maybe I'd like to be watering the ground when I am farming wood, for example. So this is very important. That's why we separate things into file. I mean, I don't know how long this video is gonna be, but I think it's long enough and we've learned a lot. Thank you so much for watching. I really, really hope you enjoyed. Honestly, I'm enjoying making this video so much, even though it's not getting the best of views. I mean, last video you helped me so much. I got to 2.5k views, which is amazing to me. And also I got like almost 50 likes, which I asked of you, and it was wow. I'm really grateful. I'm enjoying this a lot. I hope you are as well. And we are learning a lot of things during this. Yeah. So thanks so much for watching. I really hope you enjoyed, and I will see you in the next one. Bye bye for now.